Hey guys, in this video we're going to be covering Target 5B.2. Our Math 3 learning objective is I can calculate conditional probability by interpreting two-way frequency table. So our vocabulary word for this section is, well, what is conditional probability? Alright, conditional probability is the probability of an event happening if you know one event already took place. So this is going to say the probability of an event happening if you know one event already happened. So basically you've already separated, marbles already, and then you want to find the probability of picking a specific color. Or, you've separated the boys and the girls, and then you want to figure out the people that wear glasses. So something already took place. And the way that we see this written by notation is you see the probability of some event, so some event B, given A already happened. So again, if you see that little bar, the way that we would read this out loud is the probability of B given that A already took place. So again, anytime you see that bar, that means the word given. So it's whatever already happened. Now the way that we simplify this, or the way that we calculate this, is simply by finding the probability of whenever A and B occurs and dividing it by the probability of whatever happened. Alright, so something to keep in mind. On the top, you simply are multiplying, right? We use the word and on the bottom is whatever event happens second. It's the given. It's the thing that already occurred. Alright? So looking at our first two-way frequency table, we want to use that table to kind of help figure out all these probabilities. And as you can see, we see that little bar. So these are all given, which means they are conditional probabilities. So looking at letter A, it says, what is the probability of an 8th grader given she's a girl? So what we're going to be looking at is, well, we have to write out the probability of being in 8th grade. I'm going to write girl first just to keep it in order. So the probability of girl and being in 8th grade divided by whatever the probability of that second event is. Remember? So that was girl. So what is dividing by the probability of just selecting a girl? Alright, so what does this look like? Well, what is the probability of a 8th grader and being a girl? So we find 8th grader and girl in our chart, and I see right there it's a 12 out of our total. So that's going to be 12 out of 50 is on the top, right? So that's its own probability. So this fraction bar is still part of my equation, right? That's the one that's right there. Now we have to write the probability of a girl. Well, where is the probability of all my girls? That's going to be 27 still out of 50. 27 out of 50. Now, if you were to plug this in your calculator, which you can do a double fraction. What's nice is that when you have a double fraction that has the same number in the denominator, they basically end up like canceling each other out and becoming a 1. So looking at this, just to show you, so we're going to divide 12 over 50, and then you want to divide that by 27 over 50. So you can see here that we get a fraction of 4/9. Now, if you don't have a calculator, or if, you know, plugging all of that in is a lot of steps, what you're actually dividing here is 12 divided by 27. So you're kind of ignoring these 50s, because eventually when you multiply by the fraction, you have to flip the fraction, and it becomes a 1. So if you would have just simplified, you know, the numerators here, and would have written 12 divided by 27, which are my two numerators, I still get 4 9ths. So again, you don't need to plug both whole fractions in, because now that I showed you that you get the same answer, really you only need to divide the numerators. Alright, so let's practice another one. So what is the probability of being a girl given that she's in 8th grade? Alright, so the top is going to state probability of 8th graders and being a girl. But this time, my given is that I'm only looking at my 8th graders now. Right? I've separated them by grade, and then I am trying to figure out what each of them is. So what is the probability of being an 8th grade and a girl? So 8th grader and girl is still going to be 12. So I have my 12 over 50. But the probability of 8th graders now is the different part. Right now I only have 22 8th graders still out of my 50. Alright, now like what I said before, these 50s divide out and become 1. So the only numbers I really need to simplify here would be my 12 over 22. And if I write that in my calculator, I do get 6 over 11. Okay, let's keep practicing here. So, C here is the probability of boy given that they are in 7th grade. So probability of boy, so probability of 7th grade, and boy goes at the top, so where do they intersect? All over the probability of just being a 7th grader. So where does boy meet 7th grade? Well, boy meets 7th grade right here. So that's going to be our 6 over 50. Completely divided by the total of 7th graders, which is 7th graders is going to be 13 over 50. So again, what I am simplifying here is going to be 6 over 13, which does not simplify. Alright? Looking at letter E. So I'm going to go ahead and kind of erase my table now that we've kind of walked you through a couple of them. Hopefully we're using these colors now. So probability of picking a 6th grade given that you're only looking at the girls. So probability of picking a girl and being in 6th grade goes on top. And then just the probability of the second one goes on the bottom. So where does girl meet 6th grade? Well, girl meets 6th grade right here. So I'm going to have 8 over 50 as my top probability. What's the probability of being a girl? Our total then is going to be 27 out of 50. My denominators become 1, and I'm really only dividing 8 divided by 27. And 8 divided by 27 does not simplify, so that is your final probability. Alright, looking at letter D, finding the probability of being a boy and being in 7th grade is going to be on the top of my fraction here. And then the probability of just being a boy. So again, you've separated the girls and the boys, and now you're trying to figure out how many of them are in 7th grade. So boy and 7th grade is going to be, boy in 7th grade would be 6 over 50. And then the probability of just picking a boy would be 23 over 50. So I'm going to be dividing 6 over 23, which does not have a simplified fraction, so that is my answer. Alright, last example here is letter F. And I'm finding out the probability of being a 6th grader and being a boy, all over the probability of being in 6th grade. So now what I did was I separated everyone by grade level, and now I'm trying to figure out how many of the 6th graders are boys. Alright, so 6th grade and boy is at 7, so that's going to be 7 6th grade boys out of 50 total people, over the total number of 6th graders, which would be total number of 6th grade is 15. Alright, so now I'm simplifying my 7 over 15, which does not have a simplified version, so that is my answer. Alright, so that brings us to the end of activity 5B.2. Go ahead and work on that activity. Good luck.